Hello students, it's your Professor Dr. Mink and welcome to the second lecture of 2 for Chapter 5, and we're going to start at section 5.5 and the topic is nested loops. So we've already covered a loop and you have your Boolean condition, which is either pre or post body of the loop, which determines whether or not the loop will iterate or execute the body again. In a pre-test loop, the body may never be executed because the Boolean condition is evaluated as false and you can skip the body of the loop. In a post-test loop, the body gets executed once before the condition is evaluated, so it is always executed at least once. So let's focus on the body. The body of a loop can be a call to another loop, or it can include a call to another loop, and this is called a nested loop. It's a loop within a loop. Let's take a closer look. As I mentioned in the previous slide, a nested loop is a loop inside another loop, meaning a call to a loop inside the body of another loop. So the nested loop would be the inner loop and the outer loop would be the loop that started first. So an example is the hands of a clock. The hour hand makes one revolution for every 60 revolutions of the minute hand. So the minute hand would be the inner loop or the nested loop. The minute hand makes one revolution for every 60 seconds of the second hand. So the second hand would be the nested loop within the nested loop of the hour hand. So we have two levels of nesting in this example. The hour hand is the outer loop. The minute hand is nested within the outer hand. And then the second hand is nested within the minute hand loop. So for every revolution of the outer hand, the second hand makes 3,600 revolutions because it makes 60 revolutions for each revolution or iteration, if you want to use the terminology we're focusing on here. The second hand iterates 60 times every time the minute hand iterates once. And the minute hand is going to iterate 60 times for every iteration of the hour hand. So 60 times 60, 3,600 iterations of the most inner loop in this example. Here we have a coded example for the second, minute, and hour example we gave on the previous slide. Okay, so the outer loop for int hours equals 0 to 23. Okay, so each time that iterates once, it calls its inner loop, which is the int minutes equals 0 to 59. But each time that iterates once, it calls for int seconds equals 0 to 59. So let's back out from inner to outer. Int seconds is going to iterate 60 times for 0 to 59, and then it will end, and then the first iteration of int minutes equals 0 to 59 will finish, and that will go to from 0 to 1, will drop down into the body for the second iteration of the int minutes loop, and int seconds will go from 0 to 59 again. Okay, so now we've only gotten to 2 of 60 iterations of the int minutes loop, and int seconds has already iterated 120 times. Okay, so that will continue for 60 iterations of minutes, and that will end. And once that ends, we will drop back out to the in hours loop, which will go from 0 to 1. And then the whole process starts again. Okay, I'm getting a little ahead of myself, but this slide pretty much describes what I just described on the previous loop. The innermost seconds loop iterates 60 times for each iteration, each single iteration of the middle minutes loop. The middle minutes loop iterates 60 times for each iteration of the outermost loop. So 24 iterations of the outermost loop requires 1,440 iterations of the middle minutes loop, or 86,400 iterations of the innermost seconds loop. An inner loop goes through all of its iterations before it ends for each iteration of the loop it's nested within, okay? So multiple iterations of all the loops to get to the total iterations of the innermost loop. Got that? Next up is the material from Chapter 5, Section 6, where we begin to discuss more complex input devices, multi-column list boxes, checked list boxes, and combo boxes. I probably shouldn't call them devices. These are controls, but let's take a closer look. The list box control has a property named multi-column. It's a Boolean property. It's either true or false. And if you set it to true, entries can appear side by side. So in the example shown on this slide, the column width is set to 30 and multi-column is set to true. And you'll see if the size of the control is not wide enough, it will have a horizontal scroll bar that appears automatically. A checked list box is a special form of the list box. Has all the list box properties and methods that we discussed associated with the list box. However, multiple items can be selected or checked in a checked list box, whereas the list box was limited to one. There is a special check on click property that determines how many items may be checked. To determine the status of the checked items, you use the GetItemChecked method, and that determines if one of the items is checked by returning a true or false, i.e. a Boolean value. Here we have the syntax for calling that method with a specific checkbox or list box. In this case, the list box name is checked list box. We call the GetItemChecked method, and we pass an index to it. So you could use this as a Boolean statement. If that item is checked, do this, etc., etc. Here we have a coded example that includes both a loop and the GetItemsChecked example. So let's walk through this. Okay, we're declaring an integer index that will be used to specify the index of the list box. And also we're declaring an integer called int checked cities to count the number of cities checked in the list box. And then we're going to have a for loop that will step through the index numbers, i.e. the items in the list box, and will count the number of items that have been checked. So remember, our indexing is a zero-based numbering system. So for int index equals 0, we're going to start at the first index, which is always index 0. 2, and we're going to use items count to get the total count. Now remember, we have to subtract 1. If there are 10, if the count is 10 indexes, okay, we go from 0 to 9. That's why we have that -1 as the upper boundary condition for that for loop. And then we, in the body of the loop, we have an if statement. If check list box cities dot get item checked, and then we have the index being inspected. If that's true, then we increment int checked cities by 1, which started at 0. So each time we get to the next index, we check to see if the index has been checked. If it has, we increment the counter, the accumulator, int check cities by 1. And then at the end, we'll be able to use the value in int check cities to display a message box showing how many cities the user checked at runtime. Combo boxes are input controls that are very similar to list boxes. They both display a list of items to the user for selection. They both have properties for items.count, the selected index, the selected item, and the sorted properties. And both have methods that allow you to add, clear, remove, and remove at items. These properties and methods work the same with combo boxes and list boxes. We'll take a closer look at the additional combo box features next. Before you go any further in this lecture, you may want to go over to the timeline and see the video I posted of tutorial 5-9, a combo box demo running. It'll help you to understand the additional features a combo box offers over a list box. It also functions like a text box in that it has a text property, and when it's enabled, the user can enter text into a combo box, or like a list box, the user may select the text from a series of list box choices. In code, we use the CBO prefix when naming combo boxes. I wish I could put a hard stop with a password in this presentation, because I'm really asking you to please stop this and go take a look at the video. The slides here don't do this justice. Here we have simple combo box, drop-down combo box, the styles that are available. But the video I posted for 5-9 really illustrates these styles and what selection of the various styles enable and disable as far as user entry. Take a look, please, and then come back. It'll take you 5 minutes to view that video. Here we have a drop-down list combo box that behaves like a drop-down combo box, but the user may not enter text directly. Okay, it only allows the user to select items from the collection of items that you entered during design time. And once again, tutorial 5-9 demonstrates the combo box. I put a video of my version of 5-9 running, so please take a look. Here we have a summary comparison of list boxes versus combo boxes and the circumstances under which you should use each of them. So if you're restricting the user to selected items listed, if it's an empty space, use a list box. If you have limited space, use the drop-down list combo box. Remember, the drop-down list combo box does not allow the user to add items to the list. If you're allowing the user to select an item listed or enter a new item to be added to the list, you use a simple combo box if you have empty space. And if you have limited space, use the drop-down type combo box. Once again, please, if you haven't done it, I'm begging. I think I've asked you 72 times at this point in time. That's an exaggeration. I've asked you about 6 or 7 times to please review the video I posted in this timeline session, this week's timeline session. It shows a fully coded tutorial 5-9 running, and it illustrates the different types of combo boxes that you can use. Okay, next up is material from 5.7, random numbers. There's also a tutorial that I have posted that shows how you use the random object. This is a topic that is near and dear to my heart because I am of the belief that computers cannot generate a truly random number, but anyway, that's just one opinion of many, as you'll see. Let's get started and take a look at this. Random numbers are used in many games and simulations to create the effect of a random event happening. Computers, as I mentioned earlier, don't or cannot generate truly random numbers. They create what's called pseudo-random numbers, which I think is a joke, that term. But anyway, it's kind of an oxymoron. But anyway, let's not get on that topic because I sometimes rant and rave about using the word random number in relationship to a computer generating the number. So to generate a pseudo-random number in Visual Basic, we create a random object reference variable. So, for example, we're declaring rand as a new random, creates a random object in memory called rand. The rand variable can be used to call the object's method for generating random numbers. The next method can be called by a random object to generate a random integer number. And you can have an argument passed to the next method, but we'll get to that in the next slide. If you call it with no arguments, it generates a random integer between 0 and 2,147,483,647. So it has a fairly wide range of numbers that it generates from. You can pass an integer number to the next method to specify the upper limit of the random number to be generated. So in the first rectangular box, we have the code from the previous slide, except we have an argument of 100. So that means the next method, when called, will generate a random number between 0 and 99, or less than the argument passed. And the numeric range does not have to begin at 0. You can shift that upward or downward by either adding or subtracting. So, for example, in the first example in the text box at the bottom of this slide, we're passing 100 to it. So random.next 100 will generate a random number between 0 and 100. But then we're shifting that down 50. So in essence, it becomes negative 50 to 49 is the range. Now, it generates the random number first, and then we're shifting it by subtracting 50. So we haven't really manipulated the range of the next member function during the call. It's after it's called and resolved, we subtract 50 from it. In the second example, we want to go from 1 to 10. So rand.next10 will generate a random number between 0 and 9, and then we're going to shift that from 1 to 10 by adding 1 to that. And obviously we're assigning the value to int num at the end of the line of code. You can also generate a random floating point number by calling the next double method along with a rand variable, or by a rand variable. So when you call the next double method, it generates a floating point number in the range of 0.0 up to but not including 1.0. So if you want the number to fall within a larger range, you multiply it by a scaling factor. So the first rectangular box will store a value in double number, which I'm assuming is a decimal, between 0.0 and I guess 0.99999, etc. I can't remember the exact precision at this point in time. But if you want the random number to fall within a larger range, you multiply it by a scaling factor. So in the second example, the second or middle rectangular box, we have some code that generates a random number between 0 and 500, not including 500. So it will be 0 up to 499.99999, etc. If you want to shift the number, the random floating point number between 100 and 600, you would multiply it times 500 and then add 100 to shift it, just like we shifted the integer next random number. Once again, take a look at tutorial 5-10. I have that running in the timeline for this session. This slide causes me some frustration. I've already told you that using the word random with a computer-generated number is inappropriate, and the term pseudo-random is an oxymoron if you ask me. But anyway, so let's talk about the seed value. It is something you should understand. Seed value is used in the calculation that returns the next random number in the series. Here's one that really frustrates me. Using the same seed value results in the same series of random numbers. So how can you have a series of random numbers? Think about that. Really, think about that. But anyway, so it's a value that gets assigned to the random when it's declared. And so the best seed number to use is the system time, which changes every 100th of a second. And so you can specify the seed value if you choose to. And in my opinion, from my perspective, when you include a seed number, which is an optional argument, you degrade the potential of the randomness of the values being generated. Because, go back to point number 2 in this slide, using the same seed value results in the same series of random numbers. But I'll get off my high horse right now, and we'll just finish this section on random numbers, and I'll shut up. But anyway, here's how you declare a new random, a rand object as a new random with a seed of 1,000, okay? And that 1,000 as the seed value generates the same series of random numbers, okay? I guess it's useful for specific tests and validations. I've never, when I worked as a programmer, used a random number in this way, or I've never used a random number. I've never had an application that I had to code that required a random number. So, but if you use a seed number for a computer game or any type of simulation that calls the rand object a lot, which computer simulations do, it's going to get repetitive. Thus, not random. All right, I'll shut up now. Let's get on to the next topic. Thanks. If you have multiple statements that use the same control or object, they can be simplified using the with and with statement. And this is the content from Chapter 5, Section 8. Let's take a closer look. If you have multiple statements that use the same controller or object, you can simplify the code using the with and with statement. So here we have in the first rectangular box, we have 4 statements referencing the object text name. We're clearing it, and we're setting its forecolor, its back color, its border style, etc. And these can be simplified using a with and with statement. It starts with and then the object name, text name, and then .clear, .forecolor, .back color, .border style, and then end with. And it eliminates the need to repeatedly type the same control name. And in my opinion, it looks much nicer in the code and is very intuitive. I've used this multiple times. I really like the with and with statement. Tooltips, the little text messages that show when you hover over an icon, have almost become mandatory components of graphical user interface design. It's rare that I'll find a program that's written by some reputable person or organization that's a mainstream part of our society that doesn't utilize tooltips. And I'm sure you've all seen them. So let's delve into the content from section 5.9, see how we can add tooltips to our GUI. So a tooltip is, as I alluded to in the previous slide, it's a short text message that you see when you hover your mouse over a particular control. They're easy to set up in Visual Basic forms, and the tooltip control allows you to create concise help for other controls on a form. I very rarely use the help function when there are tooltips available. And graphical user interface design and use of Windows applications has become so intuitive that just hovering over a control should provide you most of the information you need to determine whether or not that's the control icon, button, etc. that you want to select. It's quite easy to add tooltip control. Display the form in the designer window and go to your toolbox and double click the tooltip, and it'll appear in the component tray, not on the form. The component tray is that little resizable region at the bottom of the designer window that holds invisible controls. Once you have the tooltip control in the component window, all the controls will now have a property for a tooltip. This new property holds the text string that's displayed for that control. So you're going to have to go back and click on the button or other control that you want to add a tooltip to, and you'll see that it now has, I believe it's under miscellaneous, you'll have a tooltip property to add the text that appears when you hover over that property. And once again, I'll show this on the coin toss tutorial. I'll post a second video of that same tutorial running. You can see how to add a tooltip to it and where that tooltip control will be and change the text that appears for the tooltip. This slide lists the relevant properties for tooltips, and you see we have an initial delay property that sets the delay before the tooltip appears. So you hover over the control, and then within a matter of seconds, depending upon the delay, the tip appears. Auto pop delay property determines how long the tooltip is displayed. Reshow delay property determines the time between the display of different tips as the user moves the mouse from one control to the next. And the automatic delay property sets these properties all at once. Once again, there will be a tutorial video for tutorial 5-11 in this week's timeline session. So check it out, and we'll cover tooltips in depth. The last section in this video covers the contents from 5.10, which is the building of tutorial 5-12, the loan calculator application. You should note that I've made this extra credit. It is a rather involved application, and in addition to your assigned application, if you want to do this to completion, I'll give you extra credit for it. So let's take a look at some tips and tricks on the last few slides in this presentation. Visual Basic has several built-in functions that perform financial calculations, and these are used in the vehicle loan calculator application. These are similar to the same functions available in Excel, and they're payment, iPayment, and P-payment. And let's take a look at each of these on the next few slides. The PMT, or payment function, returns the periodic payment amount for a loan with a fixed interest rate. And so your periodic interest rate argument is the rate of interest per period. The number of periods is the total number of months for the loan. And the loan amount is the amount of the total amount of the loan, and that's a negative number. So here's an example. Double payment, which is going to be a decimal, declared as a decimal value, equals payment, double annual interest divided by 12, okay, because if your interest is specified per year, you need to divide it by 12, and then it would be for a 24-month loan of $5,000, and that will calculate the fixed monthly payment amount for that loan. The IPMT, or interest payment function, returns the interest payment for a specific period in a loan with fixed interest and fixed monthly payments. There's the syntax IPMT. First argument passed is the periodic interest rate. It's the rate of interest per period. The second is the period for which you like the payment, and number of periods is the total number of months, and loan payment is the amount being borrowed. And once again, that's a negative number. So here's a coded example. Double interest equals iPayment. Double annual interest divided by 12 would be, say if it's a 7.5% annual interest rate loan, well, you want to get that into months, and then 6 is the number of the month for which you want to calculate the payment. 24 is the total number of months of the loan, and once again, 5,000 represented as a negative number is the total amount of the loan. P-payment, or PPMT, returns the principal payment for a specific period on a loan. And there's its syntax: P payment, periodic interest rate, the period, the number of periods, and then the loan amount as a negative value. And so very similar syntax to the other two we covered. Here is a coded example: double principal, which will hold the amount of principal paid in the month specified, and in this coded example, it's the 6 month. So the syntax is PPMT. Double annual interest, that is going to hold the annual interest rate. We're dividing by 12 because we've got 12 payments per year. We're looking for the principal paid in month 6 of a 24-month loan of $5,000. Here we have a summary of the case study for tutorial 5-12, the loan calculator. Credit union branch manager asks you to write an application named Vehicle Loan Calculator that will display the following information for a loan: the monthly payment amount, the amount of the monthly payment applied towards interest, and the amount of the monthly payment applied towards principal. So those two added together, the second and third, will equal the first. The monthly payment is broken down into interest and principal. And the credit union currently charges 8.9% annual interest for new vehicles and 9.5% interest for used vehicles. And you can see where these values are going to be used as arguments passed to those functions we just covered on the previous 2 or 3 slides. Some pseudocode: get the vehicle cost from the form, get the down payment from the form, get months from the form, and the loan equals the vehicle cost minus the down payment. Your monthly payment equals payment. And then you've got a for loop. For count equals 0 to months, interest equals I payment, principal equals P payment. Display month payment, interest, and principal in a list box within the body of that for loop. And it will show you the month, the total payment, and then the payment broken down into interest and principal for 0 to however many months the loan is given for. Here are some screen prints of the application, the vehicle loan calculator application running. And you can actually use the values, both input and output, as test values for your program. So, if you've got a $30,000 vehicle and you put $5,000 down for a 48-month loan, new vehicle is going to, if that radio button is selected, the annual interest rate will be 8.9%, and a used vehicle with the same parameters will be 9.5%. I'm going to spend $30,000. I think I'd rather purchase a new vehicle, but that's just me. So that's it for Chapter 5. Have fun doing the tutorial if you choose to for extra credit. I think it's well worth it at this point in the course. And thanks for watching. Have a great day. See you next week.